Hello everybody, welcome into another lesson. So today we're going to talk about the area of trapezoids. So here, of course, I have a trapezoid drawn, and then you have the first base, the length of the first base, and the length of the second base. And then the height of a trapezoid, again, kind of like a parallelogram or a triangle. The height is never a slanted line, it's always going to be a straight line in altitude drawn from the top base to the bottom base. The area of a trapezoid can be found by taking half the height times the sum of the two bases. That's how you find the area of a trapezoid. And it's important to remember the height is never a slanted line, it's the altitude drawn from the top base to the bottom base. So we'll get into some exercises here for trapezoids, finding the area of trapezoids. All right, see what we got here. Alright, so we're going to find the area of this trapezoid here that has two base lengths of 7 and 13, and then we see that the height is 5. So in order to find the area of this trapezoid, you're going to take 1/2 times the height, which would be 5, times the sum of your two bases, which would be 7 plus 13, which then would equal half of 5 times 20, which, let's see, 5 times 20 is 100, half of that is 50. So the area of this trapezoid then would in turn equal 50 square units. When you do the multiplication and addition and all that, you'll get the area is equal to 50 square units. I got more. All right. See what we got now. We have two right angles here, and then they give us that this trapezoid has a height of 6, this base has a length of 5, this side has a length of 10, and then this base has a length of 13. Okay. Now, we have a trapezoid here in which you got two bases. The length of the slanted side is 10, which we actually don't really need that, because since we have two right angles here, which means this line here for the height is exactly perpendicular to both bases, you can use that as the height if it's perpendicular, which this side with a length of 6 is perpendicular to both bases, therefore making it the height. So to find the area again, you'll take 1/2 times the length of that height of 6 times the length of the sum of your two bases, which, let's see, that's going to turn into half of 6 times 18, which half of 6 is 3 times 18 is 54. So the area would be about, or exactly 54 square units in this case. The area of this trapezoid then would be 54 square units. All right, what's next? Let's do one more easy one, then we'll get into a little bit harder ones. Sometimes you'll have trapezoids that are kind of tilted over too. So again, we have two right angles. This side has a length of 12. This side has a length of 14. This side has a length of 9. They give us this side has a length of 13. Okay, so we have a tilted trapezoid. Well, you notice what would appear to be the base here at the bottom is perpendicular to both of these two sides. As weird as this is, these two sides, if we remember a theorem from earlier in the course, that two lines perpendicular to the same line are parallel to each other. And bases of a trapezoid are always parallel to each other. So if you can remember that two lines perpendicular to the same line are parallel to each other, you'll be able to identify your bases, which would actually be the 14 and 9. And then 13 slanted that side, so that's not the height, but that perpendicular line to both of these bases, 12, would be considered the height. So it's actually, your bases are on the left and right, your height is at the bottom. As weird as that is, but that's how that one will work. Now to find the area, you're going to take 1/2 of your height, which is going to be 12, times the sum of your two bases, which would be 14 plus 9, which would turn into 1/2 of 12 times 23. And then we'll get an answer for the area of this trapezoid. We know half of 12 is 6, but what is 6 times 23? That one I don't know off the top of my head. It's 138. So the area of this trapezoid is 138 square units. That's what you get in the end. Now let's move on to some slightly harder exercises for area of a trapezoid. So those were the real easy ones because you had everything handed to you. But in the next few, you're not. So let's see here. We're going to have this trapezoid. This looks almost similar to what we had before. They're even kind enough to tell you that you got two right angles here. Let's see. This side is 8. This side is 5. This side is 10. But we have a missing length here. Well, let's start with one thing, okay? Let's start here. Again, two lines that are perpendicular to the same line are parallel to each other, which means this left and right side of the trapezoid are parallel, which therefore means those are actually the bases. Now, this perpendicular side to both of these bases here, this length of 8, would actually be your height. So we know the length of one of the bases, we know the length of the height, we need to find the length of this other base. Well, how are we going to do that? Auxiliary lines, that's the key. Draw auxiliary lines, okay? So you're going to go from this vertex here, from this angle here, draw a line straight over that's perpendicular to this base. And of course then you would end up forming a rectangle, right? You would form a rectangle at that point. And we know opposite sides of a rectangle are congruent. So this part of the base here has a length of 5. Now you actually have a rectangle and a right triangle. This one leg of this right triangle is 8. We'll call this missing side here X. We don't know what this missing side here, which would be the leg of this right triangle, is. But we can find it by using Pythagorean Theorem. So we'll take x squared plus 8 squared, set that equal to 10 squared, which would clearly be your hypotenuse. That means x squared plus 64 equals 100, which then means that x squared equals 36. So x would have to equal 6. So this length here now is 6. Well, what's 5 plus 6 for the length of this whole side? What would 5 plus 6 be? That'd be 11, right? Now we actually have the length of both bases and the height. We can go ahead and find the area. The area, of course, is equal to half of that height, which is 8, times the sum of your two bases, which would be 11 plus 5, which would turn into 1/2 of 8 times 16. Well, what is half of 8? That's 4. What's 4 times 16? That's 64. So the area of this trapezoid in the end would be 64 square units. So yes, sometimes you do have to use Pythagorean Theorem. And actually, we're even going to have some exercises today where we use a little bit of trig. Sometimes you need to solve for missing sides. You will have that from time to time. All right, let's see. What's next? Another good one here. They're even kind enough to give us 2 right angles for this trapezoid, which makes our lives a lot easier. This base has a length of 18. This base up here has a length of 6. So we can clearly see what the bases are since the two top parts are perpendicular to the same line. They're parallel to each other, which makes those the bases. Now, let's see, what else do we know? We know that this length here is 15. What we don't know is the height. That's something we don't know is the height. Well, once again, you're going to want to form a right triangle here in order to solve for all this. You would form a right triangle. Now, of course, you have a right triangle and a rectangle. Well, opposite sides are congruent, so we can call this the height also. Now, I should specify here that the length of this whole side is 18. That's the length of the entire side. If opposite sides of a rectangle are congruent, what does that mean? That means then that this part of this base would be 6, and if the whole length is 18, this leg of the right triangle would have to be 12. So now we can use Pythagorean Theorem to solve for the height. So we'll take our h squared plus our 12 squared. We'll set that equal to the hypotenuse of 15 squared, which would give us h squared plus 144 would be equal to 225, which would then give us h squared is equal to 81, which would mean the height itself would have to be 9. So we found the height of this trapezoid to be 9. Makes our life a lot easier now, doesn't it, since we know the height. Now that we know the height, in addition to everything else, we can find the area. So the area is equal to, of course, half the height, which would be 9, times the sum of the two bases, which would be 6 plus 18, which would mean that's equal to half of 9 times 24. Well, we can distribute this multiplication in any order. If we remember, multiplication is commutative. which means you can take half of 24 and then multiply that by 9. Half of 24 is 12, times 9 is 108. So the area of this trapezoid would be 108 square units. That's what you would get. 108 square units for this trapezoid. All right. This is definitely different. Okay, so I should specify here again that the length of this whole base is going to be 10. So this time we have an isosceles trapezoid where you have both of the legs have the same length, and across from those you have two 60-degree angles. So now what we're going to have to do this time is set up a couple of right triangles in order to figure out the height, and ultimately to figure out the length of the base, of the top base. We don't know the height or the top base, but let's set up a couple right triangles here, okay? We'll do one right over here too. Okay. Well, if you have two right triangles with a 60-degree angle, that means the only other angle that's left is a 30-degree angle. So you have two 30, 60, 90 right triangles, which means this part of the right triangle on each will be the short leg. Since it's across from a 30-degree angle, we have the hypotenuse of each right triangle is 6. That means the length of the short leg is half the length of the hypotenuse, so that would be 3. And then it would be the same here since you'd have two congruent right triangles. Now, if we have the whole length of this base being 10, you minus 3 plus 3 from that, that's 10 minus 6. This would be 4. And since you have a rectangle in the middle, that means the top base would have to have a length of 4. So now we know the length of both bases being 4 and 10. What we don't know is the length of the height. Well, the height is going to be, of course, it's across from the 60-degree angle of each right triangle. That's just the square root of 3 times the shorter leg, so the height is going to be 3 times the square root of 3. Now we can proceed to find the area. The area is equal to 1/2 of the height, which would be 3 times the square root of 3, times the sum of your two bases, which would be 4 plus 10, which would turn into half of 3 times the square root of 3 times 14. Well, half of 14 is 7, so that means the area would be exactly 21 times the square root of 3, which we're going to look for a decimal approximation to 1 decimal place. Figure out what 21 times the square root of 3 is, approximately to 1 decimal place. It's about 36.4. So the area of this trapezoid would be approximately 36.4 square units and exactly 21 times the square root of 3 square units. So that's that trapezoid. see, shouldn't be too many more left. We'll do, let's see, let's do 5 more. They won't be that bad. So we have 2 right angles here. What else do we have? We have up here, we have a 45-degree angle. This side here is 9 times the square root of 2. This side is 6. We don't know this side or this side. So let's establish something right off the rip here. That if you have these 2 lines here that are perpendicular to the same line, they're parallel to each other, which therefore means that the left and right side are actually your bases. This side here is your height. So now we can split this into a rectangle and another right triangle to be able to figure out the length of this leg here and ultimately the height in a minute. This would actually be the height. Now we would also need to figure out the length of this whole base. Well, opposite side of a rectangle is congruent, so this part of the base is 6. We need to figure out this length. But very clearly here we have a 45, 45, 90 right triangle in the top part, right? Any leg in a 45, 45, 90 right triangle is the length of the hypotenuse divided by the square root of 2. So 9 times the square root of 2 divided by the square root of 2 is just 9. So we actually found the height of the trapezoid now to be 9. And since this is a 45, 45, 90 right triangle, that means this part of the right triangle would also have to be 9. Which means now we have the length of the whole base. That is going to be 9 plus 6, which is 15. So now we know the length of both bases and the height. We can go ahead and proceed to find the area. Okay, so the area, of course, is 1/2 your height, which is half of 9, times the sum of your 2 bases, which would be 6 plus 15, which of course would give you half of 9 times 21. You're going to get a decimal answer. The area is going, let's see, let's just put this into the calculator here. It's looking a little hideous. (94.5). So the area of this trapezoid is about 94.5 square units. That's what you would get, 94.5 square units. I'm actually only going to do 3 more, but they all involve trigonometry. It's good that we practice the trig because we're going to get more of it in Algebra 2 trig. So let's do these last 3 here. All right. Good, we got that. What else are we given here? This, let's see, length of 7. This whole side here has a length of 13, we can clearly see these are your two bases. All right, and then this is a 35-degree angle. So you have a trapezoid in which you have the length of both bases, you just don't know the height. And we can't find the area until we know the height. So, like we've been doing in the past couple of exercises, you're going to have to split this into a rectangle and then and then a right triangle. So let's draw an auxiliary line here. Alright, so for the rectangle, it's actually pretty easy. Opposite sides of a rectangle are congruent. So the opposite side here, this part of the 13th segment would be 7. To find this leg here, you take 13 minus 7, you would get this would have a length of 6. What we don't know is the height, which we can find that out real quick here if we do some trig. So you have a 35-degree angle in this right triangle. The opposite side is the height, the adjacent side is 6. If you relate opposite over adjacent, what ratio is that? That's the tangent ratio. So you're going to take the tangent of 35 degrees, set that equal to your height divided by 6, which means your height is exactly equal to 6 times the tangent of 35 degrees, which of course we're going to get a 1 decimal place approximation of that height. We'll take 6 times the tangent of 35, which, make sure your calculator's in degree mode, to about 1 decimal place, that's 4.2. So the height of this trapezoid is about 4.2, approximately. Now, it's just a matter of to find your area. You're going to take 1/2 of your height, which would be half of 4.2, times the sum of your two bases, which would be 7 plus 13. Now half of 4.2, that's 2.1 times 20. So this is going to be equal to 2.1 times 20, which should end up giving you 42. So the area would be approximately equal to 42 square units. By the time you find everything, your area is approximately 42 square units. Got 2 more exercises, then we're done. All right, another trapezoid where we have, they give you right angles again, which makes your life a little bit nicer. Let's see, we have a 38-degree angle here. They give you that the length of this base is 8. They actually do give you the length of the height for once. We don't know the length of this whole base, though. We need to have the length of this base in order to be able to solve for the area. So once again, you're going to split this into a rectangle and 2 right triangles. So this time, we know the height is 6. That's easy, right? And if you have a rectangle here, opposite sides are congruent. This side is 8. What we don't know is this side. We'll call that x for a minute. So again, if you have an angle here where across from that angle you have the opposite side of 6 and the adjacent side of x, that's the tangent ratio. So the tangent of 38 degrees is going to equal the opposite side of 6 over x, which would then give you that x times the tangent of 38 degrees equals 6, which means that x is exactly equal to 6 divided by the tangent of 38 degrees. Which means now we can find the length approximately equal to 1 decimal place. We'll go ahead and do that, but make sure your calculator's in degree mode. So the height would be approximately this length here would be approximately 7.7. So when you work out the trig, this is approximately 7.7 for this leg, which means now the length of this whole base, 8 plus 7.7, that's going to be 15.7. So now we know the length of both bases and the height, we can find the area. So the area is going to be equal to half of that height of 6 times the sum of your two bases, which would be 8 plus 15.7, which would give you half of 6 times 23.7. So your area, once we do all this, we'll get a decimal approximation to 1 decimal place. So that'd be 3 times 23.7, which would be 71.1. So the area of this trapezoid is approximately equal to 71.1 square units. One more exercise and we are done. I can make this a little bit longer, I suppose. Okay. So this angle here is going to be 40 degrees. The length of the top base is 6. The length of these sides is 10. What we are missing is the length of the height and the length of the bottom base. Without those two things, we have no hope of finding the area. Well, let's establish something here first. You have an isosceles trapezoid, since you have both of the legs have the same length. If this angle's 40, that means the other also has to be 40. So now we can again split this into two right triangles and a rectangle. So let's see, since this part's a rectangle, that means this length of the base is 6. Alright, well, we need to find the height, and then we'll call each parts of these congruent right triangles, we'll call them, because they would be congruent since the hypotenuse and an acute angle are congruent, so therefore we can say both of the lengths of these segments are x. So I guess we'll start first with finding the height. If you have the opposite side of an angle and then the hypotenuse, you're relating that means it's going to be the sine ratio. So set up your sine of 40 degrees. That's going to equal your opposite side of h all over your hypotenuse of 10. The hypotenuse is equal to 10 times the sine of 40 degrees. which now we'll get a decimal approximation to about 1 decimal place. Which would be about 6.4. So, therefore, the height of this trapezoid now is about 6.4. And again, keep in mind, that's a decimal approximation. It's not an exact. Now, of course, we just need to find the length of these legs of the right triangle. Well, if you have the adjacent leg x and the hypotenuse 10, this is the cosine ratio. So you'll set up the cosine of 40 degrees is equal to the length of this leg x over the hypotenuse 10, which then, of course, x would equal 10 times the cosine of 40 degrees. And then we can do about a 1 decimal place approximation. Which would give you about 7.7. So each of these segments here is 7.7. Now, in order to find the length of this whole base, we just got to take these 3 segments and add them up, and then we'll have an answer. So let's go ahead here and find the length of this whole base. It'd be 21.4. Okay, so the length of your base here is 21.4. Now let's find the area. The area is equal to half the length of your height, which is 6.4, times the sum of your 2 bases, which would be 6 plus 21.4, which would be equal to half of 6.4 times 27.4. And now we can go ahead and get a 1 decimal place approximation for our area. And well, half of 6.4 is 3.2. That much is easy. Times 27.4. That would give you about 87.7 square units. So the area of this trapezoid is approximately 87.7 square units. So that's it for the area of trapezoids. The next lesson we're going to move on to finding the area of polygons, of regular polygons. There is actually a way to do it, like with pentagons and hexagons. We'll find the area of some of those. So I hope everyone has a great night. Take care.